Hello everyone. Welcome to Swam's online lecture series on the topic Database Management System. I am Mohammad Bukhari, working as a professor in the Department of Computer Science at Aligarh Muslim University, Aligarh. Today we are going to learn some concepts: object relational databases, object-oriented databases. So let's get ready to understand the complex concepts to enhance your database skill. Last we discussed network data model, IDMS systems, hierarchical data model, IMS system. Before I start today's lecture, let's roll back and recall the previous lecture by solving the question I have given you. The first question was, what are the two major components of IMS? The two major components of IMS information system are the IMS Database Manager and the IMS Transaction Manager. IMS Database is responsible for managing the organization and access of data within the IMS environment, while IMS Transaction Manager handles transaction processing and coordination. In IMS, two major components play a crucial roles: the IMS Database Manager and IMS Transaction Manager. DB primarily focuses on the organization and accessibility of data within the IMS ecosystem. It manages how data is structured, stored, retrieved, ensuring efficient access to information stored in the database. On the other hand, IMSTM is responsible for overseeing transaction processing and coordination within the IMS environment. The next question was, how is data organized in IMS Database Manager? In IMS Database Manager, data is organized hierarchically in tree-like structure known as database hierarchy. At the top of the hierarchy is the root segment, which contains pointers to low-level segments. Each segment represents a logical grouping of related data, and segments can contain other segments, creating a nested structure. Data within segments is stored in fields, which are the smallest unit of data storage in IMS. This hierarchical organization allows for efficient retrieval and manipulation of data with the fast access to a specific segment based on their hierarchical relationships. What is the purpose of IMS Transaction Manager? The purpose of IMS Transaction Manager is to manage and coordinate transaction processing within the IMS environment. Transactions are units of work that involve one or more database operations, such as reading, writing, or updating data. IMSTM ensures that transactions are executed in a controlled and consistent manner, coordinating access to shared resources and maintaining data integrity. It also provides features such as concurrency control, recovery management, and transaction logging to ensure the reliability and availability of the IMS system. IMSTM acts as a guardian of data integrity, enforcing transactional correctness by overseeing the execution of multiple transactions concurrently. It ensures that transactions adhere to the principle of automaticity, consistency, oscillation, and durability, thereby safeguarding the reliability of data stored within the IMS database. The last question was, What is IMS DB value unit addition and how does it differ from standard pricing? IMS DB value unit addition is a pricing option offered by IBM for IMS database manager, unlike standard pricing, which is based on the number of IMS users or the size of databases. VUE pricing is based on the amount of pricing power used by IMS system, measured in the value units. VUE pricing offers a more flexible and cost-effective option for organizations with fluctuating workloads and resource requirements. It allows organizations to pay only the processing power they consume, making it easier to scale their IMS environment according to their needs without incurring additional costs. The fundamental difference between VUE pricing and standard pricing lies in how costs are calculated. With VUE pricing, organizations are charged based on the amount of processing power consumed by their IMS environment, rather than fixed rate tied to metrics like user counts or database size. The topic which we are going to learn today includes object relational databases and object oriented databases. So the first topic is object relational databases. Object relational database management system are not just tools, they are a game changer in the world of data management. As we navigate through an increasingly data-driven landscape, object-oriented relational database management system will continue to be the a forefront and shaping how we store, retrieve, and interact with data. So buckle up because the journey through ORDBMS is bound to be exhilarating, enlightening, and full of endless possibilities. ORDBMS Object Relational Database Management System is not just an evolution, it's a revolution in data management. It expands the horizon of traditional databases, enabling them to handle a vast array of data types and relationships. We are talking beyond your typical number and strings. ORDBMS embraces complex data types like array, nested table, and user-defined types. Furthermore, ORDBMS provides a native support for object-oriented programming concepts such as inheritance, encapsulation, and polymorphism. This enables developer to work with data in a more intuitive and natural manner, leveraging familiar object-oriented paradigms to model and manipulate data effectively. So let us talk about some of the advantages of ORDBS. They work with structured query language. Object relational database can use SQL, which is language that many developers already know. This makes them more familiar and easier to use. They can be integrated. Object relational databases can be integrated into existing systems. It makes them a good choice for companies and want to upgrade their infrastructure without starting from scratch. They are good at handling structured data. Object-oriented Object relational database can handle structured data well. They are good for applications. The key feature of ORDBS includes the points you can see on the screen. Object persistence. Object-oriented database system provide mechanism for objects to persist beyond program execution, allowing data to be stored permanently in the database. Encapsulation and inheritance. They support encapsulation of data and behavior within objects as well as inheritance to promote code reuse and modalities. Complex relationships. Object-oriented database system can represent object-oriented database system can represent complex relationship between objects including one-to-one, one-to-many, and many-to-one associations. Behavioral methods. Objects in OOD system can have associated methods and functions enabling them to encapsulate behavior alongside data. Schema evolution. Object-oriented database systems often support schema evolution along the structure of objects and classes to evolve over time without disturbing existing data. DB4O. DB4O is an open source object-oriented database for Java and .NET applications, offering native support for object persistence and queries. ObjectDB. ObjectDB is a commercial object-oriented database for Java applications, providing features such as transparent persistence and support for JAP, Java Persistence API. Vercent Object Database. Vercent is enterprise-grade object-oriented database with support for complex data model, high availability, and scalability. Transactions, as you know, represent a logical unit of work that includes data operations like reading, writing, and deleting data. In object-oriented database, transactions encapsulate operations on objects, maintaining the principle of atomicity, consistency, isolation, and durability. We can say that ACID. Moving on to the concurrency control, this is where things getting interested. Concurrency control mechanism regulate access to shared data by multiple transactions, preventing conflicts and maintaining consistency. In object-oriented database, we employ techniques like locking, time stamping, and optimistic concurrency control to ensure that the transaction execute concurrently without interfering with each other. For instance, locking allows us to restrict access to shared objects, ensuring that only one transaction can modify an object at a time. Timestamp-based concurrency control assign unique stamps to transactions, enabling conflict resolution based on the order of operations. And optimistic concurrency control, well, it assumes conflicts are rare and allow transaction to proceed without locking, but checks for conflicts before committing changes. Second topic of today's lecture is object-oriented database. Object-oriented database are a type of database management system that stores data in the form of objects, Much like in object-oriented programming language, they are designed to handle complex data structure more naturally than relational databases, allowing for direct representation of real-world entities and relationships. Object-oriented database management system represent a paradigm shift in the world of database storage and manipulation. Unlike traditional relational databases that store data in tables, object-oriented database management systems store data as object, mirroring the structure of object-oriented programming languages. These objects encapsulate both data and behavior, offering a more intuitive and flexible approach to data modeling. In an object-oriented database management system, objects can inherit attributes and methods from parent objects, facilitating code reuse and promoting modularity. Now let me discuss some of the advantages of it. They work well with object-oriented programming languages. Object-oriented database management systems are made to work well with languages like Java and Python. They can work with object-oriented concepts like encapsulation and inheritance. They can handle complex data structure well. OODBs are example at handling complex data structures because they store objects rather than breaking them into individual parts. They are fast for object-oriented workloads. Object-oriented databases are fast because they are designed to work with object-oriented programming languages. They are easy to model. Object-oriented databases are easy to model because they allow developers to work with objects instead of worrying about underlying data structures. Data representation. ORM maps object-oriented data model to relational database table where object-oriented database store data directly as object. Flexibility. ORM allows developer to work with object-oriented data model in code while using a relational database backend. Object-oriented database offers native support for object-oriented concepts, providing a more seamless experience for working with objects. Performance. ORM is widely used in applications where relational databases are prevalent, providing a way to bridge the gap between the object-oriented programming and relational database. Object-oriented database is less common and tends to be used in specialized applications where the object-oriented approach is better fit for the data model. Let's talk about data integrity constraints. Object-oriented database management system support object-level integrity constraints, ensuring data consistency at the object level. Meanwhile, RDBMS relies on table-level integrity constraints to maintain data integrity within relational tables. Moving on the query language, object-oriented database management system may use a specialized query language like object query language to manipulate object. In contrast, relational database management system uses a standardized query language SQL for data retrieval and manipulation. Flexibility. Flexibility is another crucial aspect. Object-oriented database model offers flexibility for complex data model, making it ideal for applications with dynamic data structure. Conversely, relational database management system is well suited for structured data with predefined schemas, providing more grid approach to data modeling. Now let's discuss native support for object-oriented programming. Object-oriented database management system provides native support for object-oriented features, allowing developer to work directly with object. On the other hand, relational database management system relies on the relational algebra for data manipulation, which may not align or closely with object-oriented principles. Performance is also a consideration. Object-oriented database management system may offer better performance for object-oriented operations due to its native support for objects. In contrast, relational database management systems are generally optimized for relational operations such as join and aggregations. Finally, let's look at some example of each type of database management systems. For object-oriented database management system, we have DB4O and Object DB, while example of a relational database management system include MySQL, PostgreSQL, and Oracle. Now it is the conclusion of the class. So let's take a quick recap, and here are a few questions for you at home assignment. It will help you to go through all the things today's lecture again. The first question is, describe object-oriented database and explain how they differ from traditional relational database. The next question, discuss the advantage and disadvantage of using object-oriented database management system compared to relational database management system. Compare and contrast object relational database with traditional relational databases, highlighting their differences in data representation and key features. As we wrap up today's session, I believe that the discussion on the object relational databases, object-oriented databases have equipped with you with valuable insights and practical skills application to your class, to your database management system endeavors. Thank you once more for your active participation, and we eagerly anticipate your presence in our upcoming sessions.